Question 7. This is the first sort of quite tricky problem-solving type of question that we've had so far in the paper. I'm just going to turn the light on over here. So let's try to tackle this one. A plastic keyring is made by cutting a small kite out of a larger, similar kite. It's even bolded for you. That is going to be important, very important. Similar kite. So these are similar shapes. The smaller kite and the bigger kite. Show that the area of the remaining plastic is 36.75 centimeters squared. And I'm going to do most of my working out here. I will use this as well, but I'm going to do some working out here so I can draw little diagrams. So there's many different approaches to this question, but I'm going to start by this concept of them kites being similar. I'm going to work out the area of my smaller kite, and then I'm going to use the fact that they're similar to work out the area of my larger kite and go from there. So I need to work out the area of this smaller kite. Now, I need to use their similarity straight away. So I've been told that they're similar, and I've got that 10 centimeters, and I want to find out what this is in order to work out my area of this kite. But I don't know what that height is, but I do know that's 10 centimeters. Okay, but that doesn't help me because I can't compare it to this. I know this is 3.5 centimeters, but that doesn't help me because I can't compare it to the bigger kite. The corresponding thing I have is this here. Now, actually corresponds, this sort of 5 centimeter side here actually corresponds to this side here. If you imagine rotating it, that's where it would fit. But because this is a kite, these sides are equal length, I can see and I can directly compare that. So I can see that my smaller kite, if I draw my smaller kite like this, to my bigger kite, okay, the relationship between them, the linear scale factor, okay, so that one is 2, and that one is 5. So my linear scale factor is 5 divided by 2, which is 2.5. So my linear scale factor is how what I'm going to multiply by to increase that side length. It is 2.5. Okay, so to go from there to there, I need to multiply by 2.5. And conversely, to go back the other way, I would need to divide by 2.5. That works for any length here. Okay, so that helps me because I've got this length here, 10, and I want to find out this length. So if I take the 10 and I divide by 2.5, that will give me this length here. Okay, so 10 divided by 2.5, 10 divided by 2.5 uses a calculator paper, so just use it, 4, okay. So that's 4 centimeters. So this distance here is 4 centimeters. Okay, so that's the height there. Now if you have a look at this shape, we've got essentially 2 triangles. Okay? So if I just take one of these triangles, that could be my base. You see, if I'm just thinking about this triangle, this half here, then I can double everything up. But if I'm just thinking about this triangle here, it would be 4 centimeters, that would be my base, times by my height. Now my height here would be half of this. Now that is half of the 3.5, so that would be 1.75 centimeters. Okay. So this triangle here is 4 centimeters by base by 1.75 centimeters. Now that's that triangle. Now I've got 2 lots of it. Now normally for the area of a triangle you do base times height divided by 2. But I don't need to divide by 2 because I've got the other half here. And we could see, you could imagine turning this into a rectangle. If I put that round over there, and I put this part round over here, you can see that this makes a rectangle. So the area of this kite is just 4 times by 1.75. So my area of the smaller kite is equal to 4 times by 1.75, which equals, again, you'd be able to do this without a calculator, but you have a calculator, so let's use it. And that's 7 centimeters squared. Be careful here. Okay, so that's my area of my smaller kite. Now, you could now work out this and do some complicated working out, finding this distance here by multiplying up this one and doing basically the same thing for the bigger kite. But we don't need to, and it's going to waste our time. It's much quicker to use the fact that they are similar kites. Because they are similar kites, I can use the area scale factor. If my linear scale factor, so my area scale factor equals my linear scale factor squared, doesn't it? Okay, so my area scale factor here equals my linear scale factor, which is 2.5 squared. So 2.5 squared is 6.25. Okay. So what that means is to find my area of my bigger kite from the area of the smaller kite, I'm going to just times it by 6.25. So my bigger area of the bigger kite equals the area of the smaller kite, which is 7 centimeters squared, times by 6.25, which is 43.75 centimeters squared. Now, the keyring is made by cutting a small kite out of a large kite. So this is actually a hole here. And so we want to find the area of the remaining plastic. So I've got the area of the large one, and I need to take away the area of the small one. So I've got remaining plastic. Okay, so my remaining plastic equals 43.75 take away 7, which equals 36.75 centimeters squared. Well, that's it. We have shown it. Okay, we've shown what it has asked us to show here. Show that the area of the remaining plastic is this. Okay, so it's quite a few steps involved. You have to remember, if you're dealing with similar shapes, you can use scale factors, and you can also need to remember that your area scale factor is your linear scale factor squared. And use that. That makes it a quicker process. Was a tricky question. You just need to make a really, really good correction for this, and to try other similar examples with a lot of similar shapes and working with linear scale factors and area scale factors.